An overloaded function basically is two functions that have the same name. But what makes these functions different is either the number of arguments, parameters that they have, or if they both have the same number of arguments, parameters, they are different data types. Let's take a look. Here's two prototypes here. One is called square, and it's going to receive one int parameter, and here is the other one with the same name, square. It's going to receive one double parameter. And if you look down here, here is the square that's going to receive an int, and here is the square that's going to receive a double. Let's take a look at the program. The program says user int is an integer and user float is a double. Enter an int and a floating point value. So I'm going to enter 2 here and 2.2 here for user float. So user int is 2 and user float is 2.2. And it says here are the squares. Cout square user int. Now that's a call. And the argument here, user int, is 2. It's an int. So the question is, which function or procedure, which function I should say, will be used? This one that's waiting for an int parameter, or this one that's waiting for a double? It's going to go ahead and use this one. 2 is sent to number, return 2 times 2 or 4. This becomes 4. Now this is another call, square user float. It's 2.2, and this will be sent down to this one here, to this function, because the data type of this parameter is a double. So 2.2 is sent here, return 2.2 times 2.2 or 4.4 into here. This becomes 4.4. So what we use to determine which particular function will be called is the data types of the parameters involved. Now here's another example here. We have two functions called calc weekly pay. One of them is expecting just one parameter, the other one is expecting 2 parameters. So in the program, when this particular function is called, it's sending 2 arguments. So it's going to go down to the function that's expecting 2 arguments. When this one is called, it's only expecting 1 argument, so the particular function that's called is the one that has one parameter. So when you overload functions, that's 2 or more functions with the same name, the particular function that's called will be determined by the compiler. And the compiler's criteria is either the number of parameters that it's looking for, or if they're both looking for, say, 1 parameter, then the data type of those parameters must be different. One thing that's not part of the determining factor, and by the way, a term that a lot of textbooks used for this determining factor is the signature. The signature of the functions must be different. Basically, that's either the number of parameters and or the data type of those parameters. One thing that's not involved in this is the data type of the return value. In other words, this double here and this double here, they have absolutely nothing to do with the signature, the criteria for which particular function is called. It's all based on either the number of parameters or the data type of those parameters, but not the data type of the return value. Not that. That's not part of the signature. Why would we want to have overloaded functions? It's a lot easier for programmers to remember the name of a function that performs the same task. Let's just say sum. You want to sum some values, so you name a function called sum values. Well, if you're only going to have 2 values to sum, you can actually just have a sum value function that would accept 2 parameters. If you're going to have a sum value function that is going to work with 3 numbers to sum, then that function would have 3 parameters. If you're going to have a sum value function that's looking for 4 parameters or 4 values, then you're going to have 4 parameters and so forth. The programmer only has to know the name of the function, some value, and what makes each of these functions different is their parameter list. So it makes it a little easier for the programmer when you overload function names.